Yeah, I'm over here at the CAD camp station, my home computer, and this is what we're gonna do. Okay, this will be for the side and for the top. This will be the setup for it. A block with a cutout in it, holding it at the correct angle. This is what we're working on right now. Is we don't even have to have a model of the part. We just use a square with some radiuses in the corner, just a flat pattern, GXF, typical. And we're going to go around it with a 1/2 inch end mill, and then do the 1/16 radius at the top. And we're going to go down 1.25 inches, even though we only need 1 inch, because we don't want to leave a step in the middle. If we have the material and we got to flip it over, we're going to have a step in the middle, and then the vise, top of the vise, this is going to be in the vise, and then you're going to have this situation where nothing is flat. You're going to have this knob sticking on it, and it won't work. So we make it flat on both sides. Over here, yeah. So you don't want to cut it short. Anyway, I'll show you what I did. So we just made a flat pattern here. Now this line here, that's from where I just drew it, and I put a line in the middle. I just offset it each direction 1 inch, so this is 2 inches wide. Then I had a line up here, and I just offset that a 1/2 inch, and that's what that line's for. I could have taken it off, but I just left it there. Anyway, this is looking at the top. So we'll go to the first contour, and we're going to use a 1/2 inch end mill. I'd rather use a nice thick end mill. That way it won't vibrate or move as much. So it's just going to do a couple of cuts around the outside and doing 2 roughs and a finish. The finish is going to be when it's all the way to the bottom. I'm doing 2 roughs, even though I'm not taking much material off. I'm only taking maybe a 1/16 at the most. But the thing is that we got to have a fairly good finish on here, so I don't want to get a vibration going and having a hard time getting it out. So look at it from the side, and you can see the depth cuts here. See, I only got a flat line. I really don't even have the part. And then we're going to do the little end mill on the top, the little 1/16 radius tool. And it just goes around. It only does one pass. I mean, it's only taking a 1/16 off the top. That's it. So what that's going to do is that's going to do the sides and the top. So all I got left is the angle. So I'll go in here. That's the OD, and then we're going to do the, well, I call it the T-ball. So this is what it looks like. is from the side. So what I did here was I put a surface on here. If I go over here and I take the part off, there's the surface I made for it. Now this is the surface that gets cut right here, and then this surface is what we call the check surface. We don't want the end mill from here cutting into here. See, I didn't have to do the front because when the end mill comes off of this surface here, there's an angle here and it won't cut it. You see this angle on the front. The end mill won't cut that because it's basically 90 degrees to it, but it can cut the one in the back if I don't put that as a check surface or a safety surface. But so the first thing I did is we got to do the outside here, this surface here. Now everything comes off the center of the ball. So what I did was I took this line here. You notice there's no radiuses on this part. Now when I made this part with the radiuses and without the radiuses. And the reason I did that is because sometimes when you put the radiuses on there, it creates extra geometry and it's really hard to find the line you're looking for because of all that extra geometry. And sometimes you just don't need it. Like in this case, this part is so simple, you don't need it. Like the first one, I just drew the rectangle and put the radiuses in it, and that takes care of this whole surface right here and the outside of this right here, so I don't really need it. Now on this surface here, I really don't need it either, because what I did was I went in here and I made this one. If I get rid of this and I don't really need the surface either. I just created this line, which is basically a flat line, DXF again. It's not a DXF, but it's flat like a DXF. So if I go to the top, it's just that piece across, and then the radius is on the corner. If I look at it from the top, you can see that you see it wrapping around right there. It wraps around that corner. See it giving me that radius here at the bottom. See that little radius at the bottom. So I go back to the top, and here again I'm going to use the 1/2 inch end mill. Over here is the 1/2 inch end mill. And we're just going to come in. We're not even going to do the side. We're just going to pick up the edge of that radius and then go around the front. There's extra material on here, so we're going to take that off. So we're going on the front and we're taking that extra material off. A couple of passes. Then it does the same thing for different depths. Okay, now it's going to do a finish pass. So it does all the roughing, and then it comes back and it does a finish pass. And that's right there. So now we set up to do the radius on the top. So what I did was I created this surface off of that model. I just created a surface. But what I also did was I extended this surface. This is the model right here. And I extended this surface away from the model. They have a thing in here, surface, oh, what do they call it? Extend. You can extend the surfaces. So what that does, see what happens is when your end mill hits the edge of this, your end mill is gonna, especially in 3D, your end mill wants to hit the edge of the part. So if you use a 1/4 inch end mill, 1/8 of it is going to be in the part, 1/8 of it is going to be out of the part, because the center of the part is going to hit the edge of the part. So 1/8 of it, when it's coming down plunging, it's into the part already. So by extending this surface out, the outside of the end mill is off of the part. So when it starts cutting, it cuts into the part without plunging the end mill down into the parent material. It's coming off the part, so it's not plunging in the part. It's plunging in this extra piece that I put on here. So when the end mill comes down, it's not starting on the part, which it usually does. It starts right at the edge of the part. It starts off the part, so when it starts cutting, it's cutting into the part. Now it's going to take a little jab in the back. There's a couple of little pieces that it's going to cut on that I got to go into the post. When I post it, I got to take those lines out. You see those right here? It's giving me some extra cuts right here. So I just go in there when I post it and I'll take them out. But see, now it's going to start cutting across the part. See, now it's cutting across the part. It's going to climb up the part and then come off of this edge here. But see, we don't want it digging into this piece here. But like I said, on this piece here, there's an angle. It comes straight down, so this end mill is not going to hit it no matter what, because it's going to hit on the side of that ball, and it's not going to hit here. Okay. we'll take a view from the front, and you can show you why. See, it's starting off the part, so the ball of the end mill is off the part, so when it starts cutting over here, it's actually going to be in a good flute area instead of on the edge of the end mill. But it's going to do those couple of little hops right there. Like I said, I got to remove them off of the program. I mean, I could leave them in there, but I can remove them. So here we go. See how this is the part right here, and the ball of the end mill is off the part because it's not cutting that much. It's over here. So when it starts cutting, it's going to cut nice and clean. And when it exits the part, it's going to exit off the part. Those are little tricks you learn after you do it for a while. But it just goes around that part, and I got a step over of I think 15 thousandths, which will give me a pretty good finish. I mean, you know, I could change the step over to closer, but I figured, well, we'll get this part through and, you know, hit it on a little piece of sandpaper, and because over here it tells you how long it takes. So right now it's taking 8 minutes to do this operation, which isn't bad. I mean, you know, 8-9 minutes. So, you know, you figure 10 minutes, that's not bad. You know, it'll give you time to get up and get a drink of coffee, a donut. You're good to go. So anyway, that's about it. Like I told you before, you know, there's other programs that go in depth with this stuff, but I'm just kind of glossing over the highlights here. Now these holes here are from the model. Because there's no surface there, it's a hole. So it doesn't make a surface there. Now you can fill those holes in. There's a thing in here you can go and you can, it says fill holes, and that way you can make a solid piece. Because if you was to do this part with a 3D end mill, what happens is it comes over here and then it skips over the hole, and then it goes over here, skips over the hole. So you got, you know, 1, 2, 3, 4, 6 jumps in the part because it skips over the hole. So if you fill the hole in, it just skims right over the part without jumping up. Because when it sees a hole, it jumps up off the hole. Because there's no surface there, it's a hole. So rather than, you know, the end mill doesn't stay straight, flat across, it jumps when it gets to a hole, then it comes back down. Well, anyway, that's about the deal. We'll set this up, get this done, and see what happens. I'll see if I can't get this. Oh, I forgot to turn this. Yeah, I was talking about these holes back here. The end mill likes to jump up over these holes. But anyway, we'll get this done. We'll see if we can't get a little video of that. I'll show you what the fixture looks like. All right. That was exciting. A little insight there as to what it takes to make a part. And you got to figure out how you're going to hold it, how you're going to machine it, and you got to figure all this stuff out before you even make the first chip, or else when you get to the end of the part, you'll end up in a case where you can't work the part because you have no way of holding it. All right. Talk to you later.